Hey everyone, and welcome back. So today we're going to be doing an interesting one. It's called Practical 2010 of the Science Physics O-Level. Okay, so today's one is quite interesting because it's based on the burette and water pressure. Let's take a look. So basically the pressure in the liquid increases as the depth of water increases. So when we put the water in the burette and the tap's open, the pressure is greatest when the burette is full, which means the flow rate, the rate at which the water squirts out, is much faster. But then it will become slower and slower as the water pressure decreases when the height decreases. Okay, so we're actually going to experiment with this and check the flow rate. That's cool, right? Okay, so what I'm going to do first, right, is to check whether or not we have a good initial flow rate here, alright? So what we're going to do, right, is to put a burette in here. Sorry, what I meant was a funnel in the burette, okay? And then we're actually going to fill up the water, and then we're going to watch the water pour down. Oops, wow, there's a lot of water. Oop, it's dripping. Yep. Alright. Wow, okay. Yeah, that was odd. Okay, a little bit of splashback there. Alright, so I'm going to press start. We're actually going to measure the time taken for it to move from 0 to number 10. Then we're going to see whether it has a timing between 15 and 20 seconds. If it has that timing, then we're all good to go. And we are reaching it, and we're going to press now. So do we have, oh my gosh, that's great, 1763. That means that the tap over here, right, has been arranged to become quite nicely arranged such that the tap releases water at the correct rate for our experiment. That's great. Okay, so we're not going to touch the tap. We're just going to leave it there so that we can have this perfect flow rate available. Okay? And then we're going to write that number over there. What was I going to say? Oh, 1763, right? Okay, let's put it down. So 1763 seconds. That's pretty good. Okay. So once you have gotten quite good timing over there for the flow rate, then from now on we must ignore the readings on the burette. Then we only take the readings on the ruler. Okay? So now we need to choose 6 values of H between 50 cm and 5 cm and record them in table 1.2. And then we're going to record the time it takes to get from height of 50 cm of water on the ruler recording. And then we're going to move to 5 cm. So what we can do now is first predict what numbers we're going to read. In which case, the best way to do this would be to write down first. So 50 to 5 is a bit irregular. I don't have all the boxes I need for a nice regular one, but I know the starting part is faster. So what I do is I will make this 50, 40, 30, 25, 20, 15, 10. Beautiful. Okay, so we got 25 here, 20, and 15, 10, and then 5. So these are the heights that we will read. And then you can see that I need to start the stopwatch when the meniscus is at the 50 cm mark. So for the 50 cm mark, we can write 0 already. So that's how we start. Then we're going to proceed on. Okay? So let's try it out, alright? So you can see here that we never ever change the tap. Okay, the tap is still on because what we want to do is to keep that flow rate on, keep the flow rate going. Okay, so let's begin. I'm just going to fill it up again. Oh my, it's going to be a little bit of splash, isn't it? Let's go, we can do it, we can do it. Alright, there's no more splash. Wow, did I get better at this? Yeah, that's sweet. Alright, that's cool. Okay. So you can see that I'm waiting it to reach the 50 cm mark over here, and then I'm going to start the timer. Okay, and then I will start. Okay? So we're going to wait for it to go down, and then once it hits the 40 cm mark here, then we're going to record it again. Okay, they're going to check it out and record it again. So It's going down, it's going to 40. What could it be? And time. Okay, about 19 seconds. Okay? That's good. Alright. So now we're going to wait for it to get to 30 cm over here. Okay? Let's keep it going. Okay? And 30 cm would be now. I say it's 39 seconds. Alright? Alright, next one is 25. Let's keep going. 25. Okay, and it'll be now. Okay, 51. I think you got 51. Alright, next one is 20. Alright, 20. We're going to get there. Alright, as you can see, this is a very exciting experiment. 104, I think. I think I got 104, which means 64 seconds. Alright, 15. Let's go. Are we good with 15? Come, let's go. Join me. Alright. So at 15 you can see it's slowing down, and yes, 119. Okay, so that's good. I'm going to register as 119, which is actually 79 seconds. Okay. And next one we're going to do is 10 seconds, right? Okay. So that would be 136, I think. Okay. I'm just going to memorize that. I'm just going to keep this camera for the 5th second. And reaching the 5th second, and it will be 155. So we got here 136, which is 96 seconds, and 155, which is 115 seconds. Okay, and that's it. You can see here that from the time scale, at first it moved quite fast, it moved 10 cm in 19 seconds, the next one was 20 seconds, but in the next 5 cm it took a much longer time, next 5 cm took a longer time, next 5 cm took a longer time, and we will use that to draw our graph. And that's it. Thank you very much everybody for your attention, and that was Practical 2010. Alright.